Now let's take a simple example to practically demonstrate the feature selection of LASSO. So feature selection in predicting house prices using LASSO. So selecting relevant features like the number of bedrooms, square footage, and location to predict house prices. So let's begin with our first step, which is load the data and import library. So here first load the data into a pandas data frame. That's what, uh, and then import the required libraries. So that's what we'll be doing here. So let's do that. So the required libraries import pandas as PD, and from sklearn, all libraries, all modules that we require are all from sklearn. So sklearn, and then model selection is one package, pre-processing is another package, linear underscore model is another package, matrix is another package. So out of the model underscore selection package, we will be importing train test split module, and out of the pre-processing package will be importing standard scalar module, and from the linear underscore model package we will be importing lasso, and finally from the matrix package we will be importing mean squared error. And that's what the import has been done so far. And then let's load the data. Simple. Let's load the data. So for that I will be using the read underscore csv function from the pandas, and I'm gonna give the path of my data set. So let me call up the df and let's see what it consists of. So this is our data set. So it consists of bedrooms, square footage, location. Okay, let's have a quick data story about the variables in this data set. And this data set talks about house prices in a metropolitan city like Bengaluru in India. So the dataset contains information about various variables related to how to houses, such as the number of bedrooms, square footage, location, age of the house, bathrooms, garbage capacity, overall condition, and the actual price, actual house price. So let's begin with the number of bedrooms. The number of bedrooms that you see here, 514, is an important factor influencing house prices. Houses with the more bedrooms generally have higher prices as they offer more space and accommodation and accommodate larger families or provide flexibility for home offices setups. Then we have the square footage. So square footage is another significant factor affecting house prices. Larger houses with more floor area tend to have higher prices as they offer more living space and potential for customization. Then I'm going to go for the location. So the location of a house plays a crucial role in determining its price. Urban locations, typically closer to city centers or in high demand areas, tend to have higher prices compared to suburban or rural areas. The location preferences may vary based on proximity to amenities, transportation, schools, and other factors. Now let's get into the fourth one, that is age of house. The age of a house can influence its price. Older houses may have lower prices due to potential maintenance or renovation requirements, while newer houses with modern features and the amenities may command higher prices. Then we have the bathrooms. The next one that we have here is the bathrooms. So the number of bathrooms in a house is an essential feature for home buyers. Houses with more bathrooms often have higher prices as they provide convenience and comfort for residents. Then we have the garbage capacity. So garbage capacity, the garbage capacity representing the number of cars the garbage can accommodate, can impact house prices. So houses with large garbage capacities or dedicated parking spaces tend to be more desirable and may have higher prices. Now let's look into the garage capacity. So the garage capacity representing the number of cars the garage can accommodate can can impact the house prices. Houses with large garage capacities or dedicated parking spaces tend to be more desirable and may have higher prices. And then the overall condition. So the overall condition of a house reflects its maintenance and upkeep. Houses in better condition with fewer repairs or renovations required tend to have higher prices as they offer move-in ready options for buyers. So these variables collectively contribute to the determination of house prices in a metropolitan city like Bengaluru. By analyzing its data set and applying machine learning models, it's possible to predict house prices based on the features and gain insights into the factors that influence the real estate market. It's a real estate market. So here you can see the house prices which are close to the 79 lakh. It's more, it's too much because it's in Bengaluru, and of course if you go to rural Bengaluru and the prices may fall slightly, but that's also point of interest here. That's okay. So this is the data story about our data set. Now it's time to move on to the next step, and it's a data pre-processing. So encoding the location variable using one hot encoding or any suitable encoding technique. So that's what we'll be doing, and this is what the code for that. Now let's get back to the Jupyter notebook and see the encoding here, how to do that. So let's call. So our data has been loaded. Now it's time to encode the location variable using one hot encoding. So let me call that df underscore encoded. So df underscore encoded. So I'm gonna call up get underscore dummies function from the pandas, and then a respective data frame has to be given here, and then columns. So out of that, which column we want to take out, the location. So let's if you want to see how it look, df underscore encoded, and this, oh sorry, and this is what. So our this is what is our normal data frame, and location has been encoded, and what we got is uh, the location has been removed, and then in spite of that you got the location rural, location suburban, location urban. It's pretty straightforward. It's what we have used here is encoding. So I have done one hot encoding that you can see clearly. So one hot encoding is pretty straightforward. So this one will be replacing this locations, each location whichever is hot, the hot location will be replaced with one. So that's why we call it as a one hot locate. At any time one category will be hot. So here location rural, location suburban, location urban, and this is what the encoded data set that we see. Then it's time to split the data into features X and the target variable Y, and that's what we'll be doing here. So let's scroll up, and here, so this is our data frame which you have seen df encoded after encoding. So now it's time to split the data into features and target variable. As we have discussed earlier, y and df encoded house price is our target variable, and other than house price everything is our feature. That's what we put it in X, and that you can see on the screen. So now it's time. If you want to see, let me execute and see. X, you see that? Other than house price, you got the bedroom. You got the bedroom, square footage, age of house, bathrooms, garage capacity, overall condition, location, rural, location, suburban, location, urban. Then what we have here is Y. So this is what is our target variable, and this is obviously it's money. It's in lakhs of money, so that's the reason you got this format. Let's split the data into training and test sets. Split the data into training and test sets using the train underscore test underscore split from sklearn library and model underscore selection method. Let's do that now. So here if you see the step 3, split the data into training and test sets. So x underscore train, x underscore test, y underscore train, y underscore test. So I have used the class train test split, and then the first argument is features and second argument is target variable, and then test set. Test size is 20% and random seed or random state is our 42. And let's get back to the step 5. Now it's time to standardize the features. Standardize the numerical features in X using standard scalar from sklearn library pre-processing package, and that's what we'll be doing. So next step is to standardize the features. So I have instantiated the standard scalar class object, and I have referenced that class object as a scalar. Okay. So then after that I'm gonna uh, fit our x train and x test data into the scalar object using the fit transform method so that I can standardize the each and every feature that consists of. So finally, x test scaled and x train scaled both were transformed. Now let's see how they look like. So x train scaled, and this is how it's been converted, all the features, and x test also, sorry, x test scaled, and that's it. So these are all our scaled data. Next, create the LASSO model, the crux of our learning. Create the LASSO model, import LASSO from sklearn library linear underscore model package. Then create an instance of the LASSO model. Create the instance of the LASSO model or object of the LASSO model specifying the desired regularization parameters alpha and any other optional parameters if it is required, and that's what we are going to do. So the regularization parameter is pretty important here. So we are going to create or instantiate the lasso class object. So that's why I call the lasso, and then the parameter I have given alpha. It's a keyword argument is equals to 0.1. I gave this value. So you can specify the desired regularization parameter. So I gave alpha is equals to 0.1. We call it as a lambda also sometimes, but this is the terminology from our library. Okay, so now let's move to the next step. This is very important, which is perform feature selection with lasso. That's what important for us. So to do that we have to fit the lasso model on the training data using the fit method, then retrieve the coefficients of the features using the coefficient underscore attribute, then finally identify the most relevant features based on their non-zero coefficients, and this is how we do. Okay, so let's look into that operation and we will get the selected features by the lasso method. Let's see how the feature selection will be done. So this is our lasso object, and the fit method has been called from the lasso, and then I gave two arguments. One is x underscore train scaled and y underscore train. Okay, the scaled data has been given, not directly, so I gave the scaled data, and this is how it looks because there is a clear cut differences between the data, because if you see house prices, there's a big square footage in 3116, and bathrooms 1, garage capacity 3, bedrooms 5, because there is huge amount of the scaling is completely different with respect to the others. There is a huge difference between them, so that's the reason we just want to bring it them to the same stage or same level or same scaling. So that's what we just standardized everything. Okay, so then it's been fitted. Then after that, if you want to see the respective if you want to see, we have performed the feature selection with lasso. Then if you want to call up the selected features by the lasso algorithm, we have to just say x underscore train and then bring up the columns if their coefficient is not 0. Of course, if the coefficient is 0, then it's not a feature. It's not a feature for us. That's what. Let's call up the selection features and see what's going to happen. So selection features, okay. So bedroom, square footage, age of house, bathrooms, garage capacity, overall condition, location rural, location suburban, location urban. Of course, this is encoded. What you see is encoded. Location was encoded into this, and all of three, the encoded three all three variables are also selected as a feature. It also makes sense for this algorithm. So these are the selected features with respect to the lasso model, lasso algorithm. Let's go move ahead. So now it's all done, all set. Now it's time to uh, evaluate the performance of the selected features. So apply the feature selection to both the training and test sets by selecting only the relevant features. Then train a regression model, example a linear regression or random forest regressor on the training data, then evaluate the model's performance on the test data using the appropriate evaluation metrics, example mean squared error or R squared error, just to see the performance of the selected features. And that's what is the final step. So that's what we're going to do now also. So X trained selected, X test selected, both we will take, and then we will train a completely new regression model because we got the features. Now we just want to check the performance of these features with respect to target variable. For that, I'm going to use a linear regression algorithm. So from sklearn library, linear underscore model package, import linear regression module. Then I'm going to instantiate a linear regression class object, and obviously after that I'm going to call up a fit method from the linear regression object, and I'm going to give the arguments x features x train selected and y train arguments to that, and that's it. And after that, I'm going to go for the evaluation of the respective model. For that, I'm going to call up product method from the same linear regression object, which is linear regression object here for me is nothing but the regression underscore model. That is the name I have given. That's the variable name I have given it to, if given it to that object. So then we can use mean squared error to evaluate the model performance at the end, and similarly r squared value. Let's see. Anyway, this is not the core part of the feature selection. So feature selection has been done with step 7. So now these are the additional steps to make sure that whatever features were selected using lasso were actually make sense, or statistically make sense, or were actually giving the proper results after doing the evaluation with the any algorithm. So let's do it. Of course, the lasso regression with step 7, with this step it's done. Now it's time to train a regression model on the selected features, and we will use a linear regression as example. You see that? And then after that, I got the predicted values ypred, and then this ypred, and then x underscore test selected, x underscore test selected. The once you got the ypred with x test selected, then I'm going to compare the ypred with the y underscore test to check the uh, to check the performance of it, and that is for the mean squared error. Similarly, same, I'll use x underscore test selected with the y test, then I'm going to calculate the r squared for that, and let's see what is the result we are going to get it. And astonishingly, we got a mean squared error of okay, this is too big, but if you see the r squared error, sorry, I'm sorry, r squared, if you see the r squared value, it's 0.9989. It's pretty close to 1, and it's a fantastic, it's fantastic. We can say that these features makes a lot of sense with respect to the price price projection. So that's the reason it's better to continue with all these features, and this is how you do the feature selection using lasso. Lasso is nothing but your lasso, LASSO, is nothing but your least absolute shrinkage and the selection operator.